In this video, we will begin our lesson on 4.3. Now that we have learned how to balance a chemical reaction, we can now use the balanced coefficients as ratios between each compound. This big word, stoichiometry, means to use the coefficients as mole ratios. Looking at this example here, we can see the ratio from left to right is 1 to 2 to 1 to 2. For every 1 molecule of CH4, 2 molecules of O2 are needed to react, and this will create 1 mole of CO2 and 2 moles of H2O. If there were 1 dozen molecules of CH4, then 2 dozen molecules of O2 would be needed, and this would produce 1 dozen molecules of CO2 and 2 dozen molecules of H2O. Of course, we can use our new concept, the mole, for these ratios. We know that the mole equals this large number, but we don't need to use this number. We can just say that when you have 1 mole of CH4, you will need 2 moles of O2 in order to completely react. Then this will produce 1 mole of CO2 and 2 moles of H2O. Remember, just like in math, when you don't have a coefficient written, that means it is a 1. The 1 is implied. This is the first problem in problem set 4.3. We will use this chemical reaction, 2H2 to 1O2 turns into 2H2O, in order to solve. Part A says, when 3 moles of H2 reacts, how many moles of water are produced? Pause to see if you can come up with an answer before moving on. The answer is 3 moles of water will be produced. The math was actually very easy here, but let's work out the problem so we know how to show our work. We're going to start with the amount that we are given in the problem, 3 moles of H2. We're going to open up a unit conversion, as most things involve unit conversions. We're going to put mole of H2 on bottom, and we're going to set moles of H2O on top because that is what the problem is asking for. So our unit conversion is the mole ratio that we can find from the coefficients in the balanced chemical reaction. So we have 2 coefficient for the H2, so we put a 2 here. And then we have a 2 for the H2O, so we put a 2 here as well. You can see that moles of H2 are canceling. We take 3, multiply by 2, divide by 2, and we're left with 3 moles of H2O is produced. Now let's try part B. When 1.4 moles of oxygen reacts with sufficient hydrogen, how many moles of water are produced? This little portion right here, when it says it reacts with hydrogen, that's just explaining the reaction. The problem is not asking for anything to do with H2. It's asking how many moles of water are produced given a specific amount of oxygen. So we will start with the amount of oxygen given, 1.4 moles of oxygen. You can use parentheses for the unit conversion or the train track system. Either way works the same way. We're going to put our mole ratio in the unit conversion, putting moles of oxygen on the bottom so that they can cancel. And since the problem is asking for moles of water, we will put that on top because we don't want that unit to cancel. We're going to put a 1 because O2 has a coefficient of a 1 right here. And then oxygen, or H2O, has a coefficient of 2. You can see the moles of oxygen cancel, and we're left with 1.4 times 2 divided by 1. 2.8 moles of H2O was created. Let's do problem 2 together. We have a new chemical reaction with a 2 to 2 to 3 mole ratio. 5 moles of KClO3 reacts completely, forming how many moles of oxygen? So we're going to start with what the problem gives us, 5 moles of KClO3. Open up your unit conversion. We need to use the mole ratio as the unit conversion. We will put moles of KClO3 on bottom so that we can cancel the moles of KClO3. The problem is asking for moles of oxygen. So we're going to put moles of oxygen on top. Now we plug in our coefficient numbers. We're going to use a 2 because of the coefficient 2 and this 3 for this coefficient 3. So you can see our moles of KClO3 are canceling, and we have 5 times 3 divided by 2. 7.5 moles of O2 was produced. Try the second part on your own before moving on to see the answer. If 3.5 moles of KCl was produced, how many moles of KClO3 reacted? Even though it seems like we're going backwards on the chemical reaction, starting with the KCl, and we're trying to find the KClO3, the math part is still the same. So we're going to start out with what we're given. Open up your unit conversion, put moles of KCl on bottom so that they can cancel, and moles of KClO3 on top, since that is what the problem is asking for. We have a coefficient of 2 for KCl and 2 for KClO3. So you can see that we have 3.5 moles of KClO3 was required in order to produce the 3.5 moles of KCl. So you can now complete problem set 4.1 and 4.2, plus you can go on to the first 7 problems on 4.3.